Determine the angle in standard position in degrees in the given interval that passes through the given point. Give the exact values. We'll determine the angles using reference triangles as well as using the calculator. The first point is 2, 2 square root 3. Let's begin by plotting the point on the coordinate plane. 2, 2 square root 3 is in the first quadrant, roughly here, where again this point is 2, 2 square root 3, which indicates we're looking for the angle with the initial side along the positive x-axis and the terminal side passing through the given point, which would be this angle here. Recall that tangent theta is equal to y divided by x, which indicates theta is equal to arctangent or inverse tangent of y divided by x. For number 1, this indicates that theta is equal to inverse tangent of 2 square root 3 divided by 2, which if we simplify is equal to inverse tangent of square root 3 divided by 1. Having a tangent function value of square root 3 divided by 1 should remind us of a 30, 60, 90 reference triangle shown here below, where notice the tangent of 60 degrees, which equals the ratio of the opposite side to the adjacent side, is equal to square root 3 divided by 1. And because 60 degrees is in the first quadrant, we know the angle passing through the point 2, 2 square root 3 in standard position is 60 degrees. And now let's verify this on the calculator. However, it's important to remember when using the calculator, the output or range of inverse tangent or arctangent is the open interval from negative 90 degrees to positive 90 degrees, which means the calculator is only going to give us the correct angle if the point is in the first quadrant. Otherwise, it will only give us the correct reference angle for the correct quadrant. Going to the calculator, the first step is to verify the calculator is in degree mode. If I press mode, notice in the third row, degree is highlighted. Going back to the home screen, we now press inverse tangent, which is second tangent, and then square root 3 divided by 1, we can just enter square root 3 by pressing second x squared 3, right arrow, close parenthesis, and enter. And we do get 60 degrees. And now let's take a look at number 2. Let's first plot the point, negative 3, 3 square root 3. Let's just say it's approximately here, which means we're looking for the angle with the initial side along the positive x-axis, and again passing through the given point, which would be this angle here. The angle theta is equal to inverse tangent of y divided by x, which is 3 square root 3 divided by negative 3. Simplifying, we have inverse tangent of square root 3 divided by negative 1. Ignoring the sign, this still should remind us of a 30, 60, 90 reference triangle, where because the tangent of 60 degrees equals square root 3 divided by 1, to find the angle theta we're looking for, we need to sketch a 60-degree reference angle in the second quadrant, which would be this angle here. Notice if we sketch a reference triangle, we would label the short leg negative 1, the hypotenuse 2, and the long leg positive square root 3. Notice this reference triangle does give us a tangent function value of square root 3 divided by negative 1, which indicates the angle we're looking for, this angle here, is equal to 180 degrees minus the reference angle of 60 degrees, which equals 120 degrees. And now let's check this on the calculator. Remember, because 120 degrees is not in the range of inverse tangent, the calculator is not going to give us the angle we're looking for, but it will give us a reference angle that we can then sketch in the second quadrant. So again, we're going to press second tangent for inverse tangent, and then simplifying, we just have negative square root 3. Right arrow, close parenthesis, enter. And notice how the calculator gives us negative 60 degrees, which would be incorrect because it's not in the given interval. But of course, this angle does have a reference angle of 60 degrees, which we could then sketch in the second quadrant to determine the angle of 120 degrees. The other option would be to add 180 degrees to negative 60 degrees to determine the angle. And the reason that works is if we go back to the coordinate plane and sketch negative 60 degrees, the terminal side would be pointing in the opposite direction here. And if we add 180 degrees to negative 160 degrees, of course we get 120 degrees. So it is important to always remember to give the angle in the correct quadrant as well as the correct interval. And now let's move along to number 3. The point is 5 square root 3 comma negative 5. Let's just say would be roughly here. And because we're looking for an angle in the given interval, we're looking for the angle where the initial side is along the positive x-axis, the terminal side passes through the given point, and would be this angle here, rotating counterclockwise. This indicates that theta is equal to the inverse tangent of y divided by x, which is negative 5 divided by 5 square root 3, which equals inverse tangent of negative 1 divided by square root 3, which again should remind us of a 30, 60, 90 reference triangle. Ignoring the sign for a moment, notice the tangent of 30 degrees equals 1 divided by square root 3, which means 30 degrees is the reference angle in the fourth quadrant. So if the reference angle is 30 degrees, we should be able to recognize the angle theta we're looking for is equal to 360 degrees minus 30 degrees, which equals 330 degrees. And now using the calculator, we enter second tangent, negative 1 divided by square root 3, right arrow, close parenthesis, enter. And notice how the calculator gives us negative 30 degrees, which is not the angle we're looking for, but it does tell us the reference angle in the fourth quadrant would be 30 degrees, which we've already sketched. So the calculator gave us this angle here as negative 30 degrees. If we wanted to find the angle we needed, we could add 360 degrees to the angle the calculator gave us, which notice would also give us 330 degrees. So again, the important part is always to remember what quadrant the angle must be in and to make sure the angle is in the given interval. And now let's look at number 4. The point is negative 3 comma negative 3, which is in the third quadrant, roughly here. And because we're looking for an angle from 0 to 360 degrees, we're looking for this angle here. And theta equals inverse tangent of negative 3 divided by negative 3, which is equal to inverse tangent of, simplifying and keeping a fraction, we have 1 divided by 1. Having a tangent function value of 1 or 1 divided by 1 should remind us of a 45, 45, 90 reference triangle, where the tangent of 45 degrees equals the ratio of the opposite side to the adjacent side, which is 1 divided by 1, which indicates the angle we're looking for has a 45 degree reference angle in the third quadrant. So the reference angle is 45 degrees, which means the angle theta we're looking for is equal to 180 degrees plus 45 degrees, which equals 225 degrees. Going to the calculator, we enter second tangent. Well, 1 divided by 1 simplifies to 1, so we can just enter 1, close parenthesis, enter. And again, the calculator gives us 45 degrees, which is not the correct angle because it's not in the third quadrant, but it does give us the correct reference angle. If we sketch the given angle, notice 45 degrees would be this angle here. So what we could also do is add 180 degrees to 45 degrees to get the desired angle of 225 degrees. So the important part here is to always make sure the angle theta passing through the given point is in the correct quadrant as well as the correct interval. I hope you found this helpful.